welcome to CCTV. That's Coffee Club with a Volt. CCTV is a special interview podcast series that brings along the most influential people from the tech industry, tech policy, tech research, and the deep tech startup industry. In our latest episode of CCTV, we bring Rohit Kochar, who's the founder, chairperson, and CEO of Bert Labs. He is at the forefront of building technologies like AI and IoT to help industries from automotive to smart buildings become sustainable and efficient. In this episode, we will hear from Rohit on why sustainability should be a priority and how technology is helping us solve the world's biggest problems. Welcome, Rohit, to CCTV.
So many thanks, Niloy, for having me here. Look forward to this conversation. I'm sure it would be very engaging for your audience.
To start with, we want to know how to define Bert Labs as a company, the culture, the R&D, and your strategic vision behind establishing this wonderful company.
So I had spent 22 years before I founded Bert Labs in largely IT services industry. So the industry did phenomenally well for India and globally. So we have quite a few companies from India who are leading companies now in this sector, and we have created a few millions of jobs, India and globally. But one regret, if I use this word, has been with this industry and to me, we haven't innovated enough because the fundamental uh, tenet on which this industry was based was cost arbitrage. So Bert Labs was born from a thought process that we will focus on research and innovation. So that's one of the value systems which governs Bert Labs. So for example, this year we have a target of 60 patent filings, and we have already done half of it. And next year it would be 100, the following year it would be 150, 27, 28 it would be 400 filings. And these are new filings which happen in USA, in Europe, in Singapore, and in India. So that was the fundamental tenet on which Bert Labs got built. Second tenet was to solve very complex problems. So the complex problems is around sustainability today. How we can make this world net zero. How we can make this world free of poisonous gases, free of CO2 emissions, uh, and obviously, as long as a human race is alive, uh, the criticality or mission criticality of energy will be all pervasive. So therefore, the focus on energy savings, because energy saved at one place can be used at another place which is energy deficient. So that's what we are helping the world with. So this is why the company was built, and what defines our culture. Another tenet I would like to state here before we move on is to create an institution, because the fundamental requirement of building a great nation is to build institutions in all spheres of life. And we Indians haven't been very good at building institutions. So that is the third tenet why Bert Labs was founded, and this company would be built into one of the most admired global institutions, which would last forever, at least 100 years, if not more. So I hope this has been useful to your audience.
So, Rohit, we want to understand what it will be like when imagining the world's biggest problems being solved with IoT and AI.
So while it is very simple to understand, but at the same time the execution for different reasons is very challenging. Why it is simple to understand? Because it revolves around data. For hundreds of years and for several centuries, human race have been rich with data, but we haven't made it a point to store data, to save data. uh, you and I have the ability to transform the world, and that's what human race has done. All the inventions, uh, transformations in the world over the past several decades, centuries, is because of human mind, and human mind processing and analyzing and computing on the data which they perceive. Now we are building uh, algorithms where machines can do the same. So this is, to put it very simply, why AI is all pervasive in terms of solving these very complex problems for the world. Now, why it is complex? Because we have to create the infrastructure. As we create the physical infrastructure, similarly we have to create this data infrastructure or AI infrastructure. And that is what Bert Labs is doing, and Bert Labs is focused on doing in the industrial ecosystem, where the major energy guzzling happens, and therefore the major CO2 emissions, they happen. uh, so that's what the world needs to do, and that's what Bert Labs is helping the world to do. But there's a long way to go. Now, why this is difficult? Because what has been existing up till now as a fundamental thought process is total disrespect for data, total ignorant attitude towards data. Meaning, why is data useful for me? What will I do with this data? Why should I create storage space, huge compute resource for me to store data, process data, analyze data? Why should I do that? Still, when I go out there and meet with the CXOs of leading organizations across industry verticals and across geographies, including India, we get this impression. So it has to start with uh, having IoT devices and then a network which would enable both capture, sensing, and real time transmission of data. And then uh, having a centralized or decentralized data repository and a control tower for us to do magic on data with respect to storage, processing, analytics, and most important, the compute. Why I say compute? Because we at Bert Labs are developing mathematical equations, very, very complex, which runs behind deep neural networks. So therefore, on the data, computation gets done. And how do we build this ecosystem, which I've just spoken about, where we make it self-service. We make it automated, like a human mind which learns all the time, on the go, on its own. Similarly, the neural network which we give to machines, it learns all the time, on the go, on its own. So that is the ecosystem which we are in the midst of creating in the industrial ecosystem, and therefore, it adds to the complexity of application of AI and IoT to solve these complex problems.
Thank you for this extensive answer, Rohit. Now, coming back to talking about Bert Labs, we want to understand the patents you have till now in the AI and IoT technologies domain.
So, as I was sharing with you earlier, that we file patents in US, we do in Europe, Singapore, and India. These are the four jurisdictions we are doing. We have independent IP law firms engaged with us, an internal team who do all the patent filings, and before that, the process in terms of technology landscaping, prior art searches, drafting, and then after the filing, the prosecution, and then finally, the grant. We haven't yet reached a stage where we are monetizing these patents because we are a 7-year-old company. And these patents are largely around the technology. When I say technology, starting from the design of the IoT devices, there are 7 of them. Then the software which we write on these IoT devices. Then on the wireless sensor network, the software. Then on the distributed computing platform, which is an architecture of close to 30 software modules. And then finally, Bert Geminus operational digital twins. These are hybrid of deep neural network models with physics simulation, chemistry simulation, and biology simulation. And then finally, the application of reinforcement learning as a deep neural network for optimization. So, uh, starting with the architecture to the design to the script which we write, uh, and then we also focus on the application side. So, how operational digital twin will transform a chlor-alkali plant or a automobile paint shop, oven, paint booth, or material kill or cement kill or chocolate manufacturing, beverage manufacturing, uh, pharmaceutical formulation and pharmaceutical API clean rooms, or pulp and paper manufacturing, and also on the smart building, smart city side, uh, whether it is airport, whether it is hotels, hospitals, large office complexes, universities, etc. This is with the objective of helping them achieve, their net zero goals. How the AI algorithms which we have built, uh, for the first time, the use of reinforcement learning, for the first time, the use of hybrid models, which is integration of pure sciences and mathematics to solve this complex problem for these 10, 12 industry verticals. So all this has been uh, filed into patents, and patents, have been granted in these jurisdictions.
Understanding about the Bert Labs products and solutions. So, can you help our technical viewers of CCTV also understand about are these hardware and software being developed indigenously in the company itself?
Yes, and that's what I began to interact with your audience right at the beginning. That the first tenet of building Bert Labs is how we can, through research and innovation, create world-class products. Uh, so, answering your question, yes, they have been built indigenously. Uh, so, Bert Maximus is a suite of 7 IoT devices. So, Bert Mini and Bert Minicom, these are two controllers. Bert Mini is used in a greenfield manufacturing plant or a commercial building where you just have the infra of sensors, but you don't have a PLC network or a DCS or a MES. So Bert Mini gets deployed there, and Bert Minicom, where in a brownfield project with an existing PLC or DDC, which is a direct digital controller, you integrate Bert Minicom. Then there's Bert Minion, which is a smart energy meter. Bert Milo is a smart space sensor capturing thermal and air quality parameters. Then there is Bert Aksh, which is the only edge computing device in the world which can run computationally heavy AI models. So the AI computation real time on its own gets done very close to where the equipment is. So you don't have to take AI computation to the remote server of a cloud. That's a huge advantage which our client has when they license out Bird platform solution. So the latency of controls can be completely avoided. Then there is an image processing device, Bert Aksh, which captures digital and thermal images, and through our computer vision models, uh, the intelligent insights are drawn right on the edge through Bert Aksh. So the design of all these IoT devices are done by Bert Labs engineers. The software on these IoT devices are done by our engineers. Manufacturing, which is commodity because it requires CNC machines. So the process is fabrication and assembly. That's outsourced. And we are outsourcing that here in India. We have existing relationships with some of the EMS partners here in India. Then the IoT powered wireless sensor network, again developed by us. Uh, so, for the first time in the manufacturing ecosystem, in the commercial building ecosystem, most of the places, an IoT powered wireless sensor network is getting deployed. Then, multi tenant distributed computing platform, Bert Nova, it makes life very scalable for our clients. Any large business conglomerate in India or anywhere in the world across sector, they have a presence. Data of all their group companies can be stored, processed, analyzed at one place. This is not happening anywhere in the world currently as I speak with you. With Bert Nova, this is starting to happen. And obviously, over the next few years to several years, this will be aggressively out there in the global marketplace. So, what Bert Nova does is, irrespective of uh, it being hosted on a cloud server or on premise server or on edge computing devices, which is Bert Titan and Bert Aksh. It can real time process, analyze, and compute on this data. And there are close to 30 odd functions which on its own gets performed on the data. And then finally, the self serviceability of operational digital twins, reinforcement learning agents, they are also getting done as part of this distributed computing architecture. And then the brain of our solution, which is doing all the generation of control commands, which needs to be actuated real time by our controllers Bert Mini and Bert Minicom. They get created through integration of physics simulations, chemistry simulations, biology simulations, and mathematical simulation. And this operational digital twin, Bert Geminis, it gives the current live performance of manufacturing plants and buildings, and it gives predicted performance. So the prediction accuracy is 97% plus. So just visualize, and your audience can also visualize with me. If you have operational digital twin of different manufacturing plants from automobile, paint shop, cement, material kiln, caustic chlorine, electrolysis cell, and several others, where it is predicting the performance on production, quality, energy consumption, water consumption, and the prediction accuracy is 97% plus. The management of that company, the plant operators, will be able to change the future to make it better, because they will be able to re-strategize to improve the future. If the future, as per the predicted performance of Bert Geminis, is not in line with what the plan is of the company. And then finally, reinforcement learning, it enables optimization of a future state. So based on how the future looks like through the predicted environment, we optimize the future through the reinforcement learning neural network. So this is what we have built, and whatever we optimize, we real time actuate it. So it becomes a 360-degree control loop in factories and buildings.
As we discussed earlier also, Rohit, as said that computing is getting bigger, AI and IoT is the word, and is evolving across the software and hardware while we are integrating also modern technologies. One word which comes across to the modern solutions are the energy efficiency of that solution. And where the industry is today also moving across the SDG and talking about low carbon footprint. So we want to understand how Bird Labs is making it bigger and louder, the word energy efficient, and moving towards more sustainable solutions.
So this is the core of what we do, of what Bird Platform Solution enables for governments, for public and private enterprises across sectors, which is helping them save on their electrical power by 30%. So whatever is today, as I speak with you, whatever is a baseline in a pharmaceutical company, in an automobile company, material, pulp and paper, cement, FMCG, it could be soap, detergent, chocolate, beverage, toothpaste, uh, then around chemicals, specialty chemicals, steel, power plant. So we are helping them minimum with 30% on the existing KWH baseline, 20% on the existing tonnage, fuel tonnage which they consume. Now, if we end up, saving 30% for an airport from their heating and cooling system, which consumes anywhere between 60 to 70% of the overall power which an airport consumes, or a hotel, or a hospital, or a manufacturing plant. And the same is, on the fuel side, where we help them reduce by 20%, because fuel is generally used in boilers. And these are industry grade boilers used in cement, chemical, even in pharmaceuticals. And it consumes fuel, largely coal. Thermal is what India is. But outside India, there are other types of fuels which are used. But whatever it is, because we bring in efficiency on the process side, and therefore on the process side, the steam consumption goes low after Bert platform solution deployed, and therefore the steam which the boiler has to generate is less, and therefore the fuel which the boiler consumes is less. So that's how we save uh, fuel in these boilers. And similarly, there are other equipment which consumes fuel. Uh, and the most economical way for the world, to reduce on CO2 emissions is by bringing down KWH, by bringing down uh, tonnage of fuel, because you're reducing carbon footprint in the environment. And that's how we are helping large corporations across sectors achieve their net zero goals. All these clients already have net zero goals by 2032, 2039, and we are helping them with that.
Coming to again talking about modern technologies as what specifically and most decisively what you have been explaining till now, making it more interesting to understand about the modern technologies and they adhere to how the complex architectures while defining vast range of applications. So in this scenario, how do you tailor your solutions meeting individual customer demand?
Yeah, that's a very good question. And the most trickiest part of building a scalable deep tech, or a scalable AI distributed computing, IoT, IoT innovation. So, what we have done from day one at Bert Labs since 2017, one, obviously, we established this fact that scalability is most important. Because if you have to create one of the largest technology global conglomerates uh, within a time period, scalability and giving your clients the comfort of scalability is extremely important. So, what we did is we identified 8 to 10 physics principles, 8 to 10 chemical engineering principles, which runs behind these process equipment, utility equipment, these manufacturing process line. And as a first step, we started to simulate them. And we got the output of those simulations, which gave us, that at a design level, how these equipments are performing. The second step, what we took is we collaborated with universities, India and globally. And this collaboration gave us data. And on that data, we trained our first principle trained models. So that's the further learning which our AI models went through. Third step, what we did was to collaborate with our clients, and clients, sharing with us the data which they already have through building management system, through DCS, MES system, And on that data, we further train these pre-trained models, which already had gone through two levels of training. And this time around, these models, they learnt about the client plant, because every plant, every equipment has a distinct characteristic. Like every human being is different. So the model has to learn about it. So that's the third level of learning which our models, go through. The fourth level of learning is when Bert Maximus IoT devices they get deployed for real-time data capture. So on that real-time data, our models go through the fourth level of learning, and this learning is real-time. Whatever a plant or a building is going through, the model is learning on its own real-time. So this is how we have lent scalability to the development and deployment of Bert Geminis operational digital twins and reinforcement learning optimization agents. Then, around wireless sensor network Bert Curious, we ensured that it's a very dynamic network. So when we do that, the architecture, the design which we have, the logic which we develop, how we write our code, and some of the technology stacks which we used or developed, it ensured that we develop a very dynamic network deployed in airport, can be deployed in hotels, hospitals, can be deployed in manufacturing plants without any changes. It's a plug and play. Then around IoT devices, for example, Bert Minicom, our controller, it can work with any controller. Why? Because we have a OPC UA, OPC DA variant of Bert Minicom. We have Profinet, Profibus, CC-Link, CAN bus, BACnet, Modbus. These are all communication protocols between two controllers. So Bert Minicom, it has all these variants. So this is how we lend scalability from day one. So today, a new client, uh, Bert platform solution can be bespoke for it to learn and to be ready for deployment in 1 month to 3 months. Why this range? Because 1 month, if the data quality is very, very high, but if the data quality available from a particular client on a particular site, factory or building, is not adequate, then we end up taking more time. But scalability is the number one fundamental tenet on which Bird platform solution is getting built.
Generically talking, Rohit, so how do you think generically how the deep tech startup ecosystem is growing in India? Having said this, when there's a recent draft by the government also backing and bringing some new policies and backing the ecosystem, and what is a major challenge, if any, you see to have a successful deep startup company in this country?
No, there is a phenomenal support from state governments and from the central government for early stage companies, and more importantly for deep tech companies, and in deep tech companies particularly for AI companies. So Bert Labs has been blessed with a lot of opportunities to be part of global innovation alliances, whether it is set up by Karnataka government or India government. And we have been part of several delegations within India and outside India, within Europe, within APAC, Singapore, within UAE, and within USA, and even in Japan. And we obviously come to know about a lot of other deep tech companies doing phenomenal work in several areas in healthcare, life sciences, uh, in mobility, and very, very tangible use cases for you and I in our daily life, as well as for enterprises to solve very specific problems. And the government support in terms of ensuring that we get the right platform within India and on a global stage. It is there, for all these companies to leverage and to maximize this leverage. Uh, Other than this, there's a lot of incentive for research and innovation. So that obviously should continue because it encourages an environment where there are a lot of constraints. Early stage company, they live through a lot of constraints, and most of the companies, they start with research and innovation, but they are not able to continue it beyond a point because of constraints. So these incentives obviously help in ensuring that there's a consistent focus and execution on research and innovation, because that's a fundamental. It has saddened me for all these years where in different areas, from electronic goods to other areas, there have been a lot of startups uh, and grown to reasonable scale and size and customer base. But because they didn't continue their research and innovation and therefore continue to build their own world class products, they ended up becoming system integrators, or they ended up becoming a firm which white labels a foreign product here in India. So, government support on promoting research and innovation uh, is absolutely phenomenal, and it needs to continue. It's fundamentally important. And then, because government ensures that there is a platform for all these early stage companies to come together and therefore get to know of each other, and then explore synergies and explore uh, collaborations, because today technology is all about collaboration. It's becoming very, very democratic, and it needs to be this way. Otherwise, you will not be able to sustain yourself. The challenge of sustaining this is to build business models around this, uh, which would lead to all these companies becoming successful enterprises where they become self reliant, not just on their working capital requirement, but also on fueling their own research and innovation and their own expansion, business expansion. Now that is an area which is a concern. Otherwise, we would have had a lot of early stage companies becoming mid-sized companies, becoming large companies, but that's not the fact. How many deep tech AI IoT companies, they become companies of reasonable scale, size, revenue, profitability, customer base, cash flow, etc. You can count on your fingers. That's about it. So that is one challenge which uh, we have to meet as an ecosystem. But obviously, most importantly, companies need to have human capital to ensure that there are strong business models which are in place around a very sound product or technology or innovation. And these go to market strategies, they are executed well for uh, client acquisitions and business growth.
So, lastly, to understand, as we have pretty less time left, in the last 5 minutes, if I want to club two questions to one, when you have talked about human capital, uh, yes, India has been around the engineering globus for ages now, for decades now, rather, to be very specific. So, do you still think, building a company and there is a talent gap in the country still pervasive? And secondly, to club with it, how many more Bert labs can we see growing across the country and globally? So, what are your expansion plans also?
This is a very, very pertinent question, Niloy, and your audience should listen to this very carefully, and all of us should be in this together. While India is the uh, mass employee provider to the world, not just to itself, but at the same time, there is a very concerning trend which is setting in, and that trend is ensuring that the employability is very, very low of students who are coming out of engineering institutions, uh, because this is hardcore engineering talent which we need. Students, with BTech, MTech, PhD scholars. And why the employability factor is very low? Among several other reasons. One reason is people in the early 20s, they don't want to work hard. One has to understand the reason why the fundamental mindset is not to work hard. Uh, we need to stop aping the West, how European countries they live their lives, uh, where 35 hours in a week is a norm. In India, we can't live with this norm. If you look around us anywhere within India, there is a lot of work which still is remaining from all perspective to make India a developed nation from a developing nation. In fact, on quite a few parameters, we are underdeveloped. We are not even developing. And it is Indians who have to do this, make this change. And therefore, working hard is fundamentally needed. And there's no debate between hard work and smart work, because we are talking about people with basic intellect. And obviously, we are expected to work smartly. But along with smart work, we require huge effort, huge effort of smart work. So, this is what Bert Labs is trying and will continue to try to work with universities, to work with chancellors, vice chancellors, deans, directors, professors of these universities, institutions, and how people in their third year, fourth year doing their masters in engineering colleges, uh, they are taught the virtues of hard work. And then, the other fundamental etiquettes of being in the workforce, that also is extremely important for us to work towards increasing the employability of the workforce here in India. Now, our plans in terms of the global growth is, we would be in Europe setting up our offices. We are doing that as I speak with you. Whether it is office infra, whether it is human capital, where we hire locals, train them on advanced technologies until the point we start experiencing lack of talent in those geographies. Uh, and then set up Bert Labs research, because we would like to tap into the science and technology talent of European countries, of uh, USA, of Singapore, and other places. So the Bert Labs research hub will be in Bangalore, will be in Germany, will be at a couple of places more in Europe, will be in USA, and it will solutionize innovation for companies in these geographies. So the client has the comfort that solutionizing of their problem statements is happening very close to where they are. So we are aiming for 1 billion US dollar revenue as our first major milestone in 4 to 5 years from now. Take the company for IPO filing, US and India simultaneously, and it would be very, very profitable, gross margin, operating margin, because this is a pure product platform play. And 100 million will come from India as a market, 300 million will come from Europe as a market, US will contribute 400 million, and APAC MENA will contribute 200 million. So that's the global expansion, and obviously I have already shared with you in terms of innovation, that also will be global. Talent base will also be global. So while this will always be an India headquartered company, a company from India, but at the same time, it will be a company in Germany, company in France, company in Austria, company in UK, company in US, company in Singapore, company in UAE. So this is how we are building this company globally, both in terms of business growth and innovation.
To conclude with, in this episode of CCTV, that's Coffee Club with a Volt, I want to conclude, put my ending words saying this, that there's a difference between a vision and pragmatism. So when our complete discussion was happening, I was looking at Rohit, understanding about how a quaint man, how a possessed and well learned man can describe technology with literature to the vision of future. This was Rohit Kochar from Bert Labs for you. Keep watching CCTV as we have more exciting videos just for you in the coming time. Thank you.
Thank you very much, Niloy.